And I only sent out the spiral answers this morning, so I'm just going to wait until tomorrow to go over that. And so tomorrow, those questions alongside tonight's homework questions will be the ones that are eligible for the homework quiz. Okay? But I'll give you some time to look at those answers, process, and address anything that you weren't sure of. Okay, so once we're done with just straight up simplifying with rational expressions, we're moving to multiplying and dividing. Just out of curiosity, how do you remember multiplying this? How do you multiply fractions? What does this equal? Go ahead, Grace. 2 over 35. Pretty easy, right? Do you remember maybe what you did to do something like this? 2 over 9 times 18 over 6. Nope, you don't need the same denominator with multiplying. Needing a common denominator is when you're adding and subtracting. So you definitely do not want to waste your time doing that. Like Grace did in the first one, you just multiply across and multiply across. 2 times 1 is 2, 5 times 7 is 35. You could just multiply across here. 2 times 18 is 36 and 9 times 6 is 54, but that will then need some simplifying. So with something like this, we can simplify prior to multiplying, which makes your life easier. The 2 and the 6 will reduce to 1 and 3. The 18 and the 9 will reduce to 2 and 1. And then you can just multiply across. 1 times 2 is 2, and 1 times 3 is 3. So it's just 2/3. Do you remember that? Okay. How about dividing? What if we did 2/5 divided by 1/7? How do you divide fractions? Not to be confused with KFC. You know what KCF means? Keep, change, flip. You don't divide fractions, you instead rewrite it as multiplying by the reciprocal. So the 2/5 stays the same, we keep. We change the division to multiplication, and we flip the 1/7 to 7 over 1. And then we multiply across. 2 times 7 is 14 over 5 times 1 is 5. Okay? So multiplying and dividing is actually easier, Cameron, than adding and subtracting, which we'll get to tomorrow, because with adding and subtracting, you have to get a common denominator, and we all remember that that was a pain in the butt. Multiplying and dividing is great because we can just do it. Okay? All right. So in part A, here I already did, we're not going to do that. That's middle school stuff, but I was just writing that like I did up top to get you to remember kind of what it was that we were doing. So again, we're going to be dealing with monomials and polynomials. And 100% if you're dealing with polynomials, like in example B, you need to factor first. So starting, and there's a ton of factoring I've told you in this chapter. This particular problem calls for 4 different rounds of factoring. First, this one, Evan, what does this factor into? Good. Then we have this one. This is a guess and check type problem or a splitting the middle term. Honestly, if you're going to practice until you're great at one of those 2 methods, guessing and checking is much faster, especially in this case where we have a plain old x squared. So we have x and x. Who can tell me what's going to multiply to get -6 and also is going to work to make our outer and inner be -x? McKenna? +2, -3. Excellent. Times. What kind of factoring up on the top right? What does that call for? Jake Hutch? We've got grouping as an option. We've got split the middle, slash guess and check. We've got difference of perfect squares. Have I listed it yet? We've got difference of perfect cubes. We've got sum of perfect cubes. Have I listed it yet? Jake, have you come up with it yet? Maddie, tell them what it is. GCF. These both can be divided. What's the GCF now, Jake? 3x. And you're left with x plus 5. Denominator, last round of factoring. What method does that call for, Kaylee M? GCF, what is the GCF? 6x. I'm left with x minus 2. Okay, so now, within even just the first fraction, do we all see the x plus 2 and the x plus 2? Numerator, denominator, cancel. In the first numerator and in the second denominator, and that's fine, you can go diagonally and cross out, right? That's what we did up here. We did the 2 with the 6 and the 18 with the 9. You're kind of cross-canceling. As long as one's in the numerator and one's in the denominator, x minus 2 and x minus 2, gone. So that's it for our binomials. How about our monomials? 3x and 6x. 3 and 6 cancels to become what and what? 1 and 2. And x just straight up cancels, right? X divided by x cancels. So if I scan across my numerator, I just have an x plus 5, right? The positive 1 is unnecessary. And across my denominator, I have 2, and then a parentheses x minus 3. There we are. Any questions on that? Okay, see why you have to be good at factoring? Maybe just a little bit? Okay. Exercise 2. Let's do B first. It's a monomial one. It's complicated, right? A lot going on. So, I don't know, Aiden, pick something. Well, you don't factor monomials. Monomials are already kind of all individual factors in and of themselves. So, like cancellation type stuff. Is anything... Okay, so 6 and 4. So he's doing 6 and 4 reduces to 3 and 2. What else? John. No. There's a boatload that we can cancel. How about, let's stick with the numbers. How about the 3 with the 9? What is that going to reduce to? 1 and 3. What else with the numbers? We'll finish that off. Lydia? Good. The 2 from the bottom and the 10 from the top, 1 and 5. So there's our numbers. If that is kind of messy to you and you want to rewrite it, you can. That's fine. But then we got to start hacking away at our x's. So what would you do maybe first, Andrew? Oh, so you're going to y's. Okay, this y squared on the bottom left, this y squared in the top right, gone. Okay, something else. Let's stick with the y's because that's the road Andrew went down. What can I do with my y's? Connor? From here. Yeah, you can do something. Who can help Connor out? What do I do with a y to the third and a y to the seventh? Correct. Where? On the bottom. Y to the fourth on the bottom. Because all three of these are going to cancel with 3 out of the 7 of those. And if 3 out of the 7 canceled, we're left with y to the fourth. Okay, still not done with our x's. Kaylee? The what? They cannot. Someone tell her why they can't cancel. Bo? Both on the denominator. We're looking for something over itself, sort of. Okay? Would someone else tell me? Isaiah? This one? This one? Okay, so he's dealing with these two. Both of these from the top are going to cancel with 2 of the 5 on the bottom, making x to the third. Now, you didn't have to go through it that way. He could have canceled the one just above it with, instead had 1 of the 5 canceling, as long as it's top to bottom. So since he did it that way, we'll let this x here, there's 1 up top left, cancel with 1 of the 5 here. So this one up top is totally gone, and the x to the 5th becomes x to the 4th. You got to be pretty neat about this, as you can see, because it's easy to kind of, not realize that you already crossed something out, or you didn't cross something out and forget about it. But what's left on top? 5. 1 times 5, 5. What's on the denominator? 1 times x to the 4th times 3 times x to the 3rd times y to the 4th. Nate? Perfect. 3x to the 7th, y to the 4th. Because he had an x to the 4th times an x to the 3rd, there's a bit of exponent rules going on here. Okay? Now, I don't want you to do this, but I want you to watch, because I'm going to readdress this problem. I don't think I would ever multiply the numbers first. I would still do the numbers the same way. 3 and 2, 1 and 5, 3 and 9 becomes 1 and 3. But I might do this. Once I get the numbers all simplified, I might make it 5 over 3. And then up top, I've got x squared times x, which is x cubed. Y cubed times y squared, which is y to the 5th. On the denominator, x to the 5th is x to the 10th. Y squared, y to the 7th is y to the 9th. And then your 5/3 is still going on, but your x to the 3rd cancels fully with 3 of the 10, leaving x to the 7th. And then all 5 of these are going to cancel with 5 of the 9 there, making y to the 4th. So I did mine more through exponent rules almost than the canceling, which can be a little bit clearer. Like I said, I would still do the numbers with that canceling in mind, because if I didn't, if I just multiplied, I'd get 60 over 36. 6 times 10 over 4 times 9. Not that that's a problem. That'll still reduce to 5/3, but sometimes when you make your numbers gigantic, it's harder to simplify them. But I think with the letters, it's easy. Again, clearly order doesn't matter. I got the same answer no matter which way I did it, but just an option, whatever works better for you. Okay? We don't have as much of a choice with polynomials, so go down to D. What type of factoring? Up top, Kirsten. Good. 3 minus x, 3 plus x. What type of factoring on the bottom left? Maggie? Good. Take out a 2x squared. Leaves you with x minus 3 times. Jordan, top right. Good. Take out a 4x. Left with x minus 1. Micah, bottom right. Yep. or guess and check, whatever you want. I'm going to guess and check. It's going to be x and x, has to be. The only way to make 3 is 3 and 1, or 1 and 3, but it doesn't matter the order because they're both plain old x's. It's going to be a, what's the plus minus combo going to be? Who knows? Plus 3 minus 1. Good, Isaiah. And then that'll make your outer negative x plus your inner 3x. Negative 1 plus 3 makes the positive 2. Okay? So now, what can I start hacking away at? Aiden? The 2x minus 1's good. X minus 1, gone. What else? Nathan? Good. 3 minus x and x minus 3, but put a negative 1 in your numerator because that order of subtraction was reversed. Next. What else? What else? Bo. Not here. They do cancel, but this is not a negative 1 scenario. Why? But why? Why is it different than the 3 minus x, x minus 3? Right. The different order of subtraction matters. The different order of division, those are technically the same thing. 3 plus x, x plus 3. Because order of addition doesn't matter. So that's a complete wash. What else? We're down to the monomials, Nate. Okay, how so? Well, let's start with just the numbers. The 4 and the 2 are going to reduce to 2 and 1. We can just cross out that thing. We don't have to put a 1 there. And then the x and the x squared, which one entirely cancels out? The x, leaving just x in our denominator. So now when you look across, what do we have in our numerator? Kaylee? Negative 2 over x. That's it. Okay? All right, so now we jump to the bottom where we divide our fractions. I remind you of keep, change, flip. So maybe we do that first. 1 over n plus 9, there's our keep. Division to multiplication, there's our change. And then flip makes 3n minus 18 over 6 minus n. So it's just one additional step. And then it's the same as any multiplication problem where we have to jump into factoring. The 1 can't be factored, so I'm leaving that alone. N plus 9 can't be factored. I'm leaving that alone. How about the top right? What do you think, John? So what do I take out? And what's left? Okay. Over, denominator, nothing. So now what can I do to cancel, if anything? Cameron? Like cancel out this 3 with this 9 and make it like 1 and 3. You can't do that because then you're canceling pieces of polynomials, which we can't do. Which reminds me, if you have binomials, now this binomial doesn't need parentheses, but I think just to help you resist the temptation, you can only cross out things like in their entirety. I cannot cross out like a piece of that binomial. Grace? Yes, n minus 6, 6 minus n. Cancel, but we get a negative 1 up top. And that's really it. So our overall numerator is what? Negative 3 over n plus 9. Good. Okay. More of the same. Let's jump to the multiple choice. And it's just the division, you know, without the divided sign. It just actually says the words. So the first thing we're going to do is we're going to keep that over 3x. We're going to change division to multiplication, and we're going to flip, aka the reciprocal, 9x over x plus 5. And then what can we factor here, Kaylee? Well, that's not factoring. You're already into the cancel part. We want to factor first, then we'll do all the canceling at once. Andrew? Good. So now that everything's factored, I'm also going to throw some parentheses around that binomial just for visual purposes, make it look cleaner. Now, Kaylee, the 3x and the 9x, what about it? Right, so the 3 and 9, the 3 is going to cancel, the 9 is going to become a 3, and then the x and the x are just a complete wash. So yes, it's just a 3 up top, right? What else? Cameron? X plus 5, very good. And then that's it. So I have a 3 and an x minus 5. Which one is an equivalent version of that, Grace? Very good. So they just distributed it, which is fine. We have it. Okay? I want you to go back up and do C. Raise your hand if you're done. Okay. We'll take another minute.
one factor